Hello everyone and welcome to a new Decode tutorial. Today I want to talk about the new Llama 3.2 vision model that just dropped. And many people can, already use it for the text part, but I found it quite, cumbersome or difficult to use for the image part, the image recognition and all the use case that you can do with the language model. So I thought it would be interesting to make a small tutorial about how to use it and how to deploy it as an API. And so the first thing you need to do is to go on the Hugging Face on this URL right here and accept the Meta license. So if technically it's not as restricted in Europe, so you didn't hear it from me, but you can change your country. And then you should be fine. You just need to basically get validated by Meta, and after in a few 1-2 hours you should receive an email, and then you should have full access to the dataset. And you need this because the second thing you need to do is get the Hugging Face token. So when you go here in your settings and you go and access tokens, here you just need to create a new one and get the read permission. And then you're going to copy this string here that allows you to, from the code, to get access and download the model. So if we go back here, we can also already test the API right there, but we want to have our own and be completely independent. So I made some code for this that was actually based on litserve, and actually this is where I took the example. So litserve is another service that is offering you, it's an open source Python code base, but also they offer you this kind of premium cloud so that you can deploy, and they have their own GPUs and everything. But I just thought that we could use this as basis, but I had to fix some of the things in the code to make it work. And here I try to make a simple, step-by-step repository. You just need to install it, and technically it should work. So let's go over it just together and see how it works. And then we will develop a small front end so we can test the images. So here I'm in the Visual Studio. I don't know what you guys use to code, but this is my go-to tool. And it's pretty simple. This is the README, and it's based on poetry, right? So the poetry, if you don't know what it is, it's the package manager for Python, so that you can install and have many dependencies, a bit better than pip that you may be familiar with. So we're just gonna follow the usage, right? I'm gonna use the poetry shell here to activate the virtual environment. Of course, if you didn't install the package before, you need to just clone the repo and install it first, so you have the tool. Of course, you need to install poetry before. But this is if you're familiar with Python, this should be very simple. And then we basically have the virtual environment activated, and we just need to run the server, which is here. So let's go and see what we have inside. I'm gonna put this down a bit. So basically, this is exactly the example that they took, but since we want to deploy this as an API, at least locally, you may need to activate the CORS middleware. So if you don't know what CORS is, it's the cross-origin resource scripting, I think, which basically means that you allow things from your website, people from your website to access the resources. So when it's on localhost, it's fine. It's not going to be HTTPS, and Chrome or any browser allows you to actually access it. But if you need to access it from another server that you own, and this is going to be the example we do with cables, then you need to activate this. So I had to dig inside the documentation and the issues to find how it is. litserve, it's simply a fast API server. So they work exactly the same. They put their own flavor on top of it and try to optimize the models to serve. So that's more optimized than a raw fast API, but you still can connect both as you would before. So what I added here was just to have the CORS middleware so that you can anyone on earth can access your machine. So be careful when you do this. This is just for test. This is not supposed to be for production. Production, you will need to add something on top of it to restrict or to to make sure that you have a login before you can access your computer. And what's important here is that it also specified the OpenAI spec. So it means that the server is going to act as if it were as if it was an OpenAI server. So if you have any code that is already working with OpenAI API, this should work as well. And here we can simply specify the port. I put this one. You can put any port you want. And yeah, that's it. So when I do this, I'm here and I do Python server.py. Hopefully I should be able to run this. So I'm gonna just simply launch it again. I kill my tmux version of it. So okay, now we have our server and it's running. Basically populating my GPU with the models. See, loading checkpoint shards. And when this is going to be finished, the server is going to be ready for us to request it. Okay, setup complete. It's there. Now, I also made, based on the examples that they put, a client. So I can open a new terminal just next to it and simply use this client.py here. So let me show it to you. This is a Python client, right? So here we would basically need to upload an image. And for now, detect JPEG, PNG, or a GIF. And you encode it as base64, which is going to be exactly what we're going to use when we're going to serve this from the web. And you see, this is the structure. It's exactly what OpenAI, the API, accepts, right? You create a list of messages, but here there's only one message with the query, so the text that you want, and the image URL. So you want to describe here. And you can also specify, in this case here, the tokens and the number of maximum tokens and the temperature. So this is just a simple request, you post there and you have it. So here I made this Python client, so you can specify from the terminal the image, the query, and the port to connect to the server. So let's try this. First, I need to activate again. It's a new shell. I need to activate the poetry so that all the environment is loaded, and then I can do Python client, and I already have this here. The path is just animals. I have just a small image. If you look here, there I have this animal images that I want to describe and see, and my query is going to be describe what you see. With the quote. Sorry. And just one quote is enough. I'm not sure why. Only one quote should be enough. Now it's running. It takes a bit of time. It depends, of course, on the GPU that you have. And here I have the answer. The image shows a heart-warming scene of 3 animals standing together in the snow field. So now let's see the image so that you can verify. And here, this is my image. And this is the description that we got. So it works, right? We basically send the image through base64 and we got the answer as the description. So now the goal would be to create a bit more, a better interface so that we can query this. This you can already use in all your clients in Python if you need to embed the model in another project, which actually I need for work. But I just also want to show you how we can quickly make a front end for this so that you can simply upload an image and see and test the possibilities of the model. So to do this, we still have our server, right? It's going to be there. It's going to be running on localhost. It's there on the port 111. Okay, so that's our server. Now I'm going to quickly switch to here. I'm going to go back and let's try to show you how I made the front end. So as you know from this channel, we like the CablesGL framework. So I thought it would be actually quite convenient and easy to make a front end here. So the front end is simple. You have a sidebar where you can upload a file, type your query, and run it. So how does it work? We have the sidebar node. I put this up here to make it a bit larger, to be easy to describe the content. This is the main up here where you can specify the image. And then I could have filter actually only images file, but it's fine for now. And so when this is gonna be, when I'm gonna choose a file here, if I go on desktop test images and yeah, the animals here, this is gonna create the embedding and it's not, sorry, not an embedding, but just a description as base64. So this image, it's the string of bytes of this image is transformed into a base64 description, as you can see here, and this is exactly what we need to send to our server for it to be described. But we need to describe this in the API that our server expects based on OpenAI API. So we need to create this kind of API structure and then replace basically here the strings that we want, so the query or the image URL, and then you can also specify the token or temperature. This is what the server expects as JSON. So this is what I did here. I took the API, I parsed it into a JSON object, and you see what I'm gonna do in the next ops is I'm gonna set the query here. So I'm using this op here, and you will not find this in the standard cables library because this is an op that I made that allows me to set just an object, any value to an object. Actually, it can be a string, a number, anything you want, but also understands the structure. So in one go, I can go deep inside a nested structure and set only this value. So this doesn't work with the basic object set numbers or that, for instance, you have in cables. So this is why I use this one. Here it's just in one-liner. So in one case, I set the text, and in other one I set the URL, which is the base64 that we talked about right here. So that's all we need, and then we can specify the tokens and the temperature. This is all we need to send to create the object, and then send it here with this HTTP request, and we know this is going to be a post request, and that's it. That's all we need to do to send data to our server. So what we see here on the left is simply just a way to first put the image here on the screen. So I put just an orbit control, a bit of transform to make it closer to the camera, a material. So I'm transforming my base64 to a texture, and now we are talking about WebGL texture. You see that I can put it in 3D. And I'm applying this texture to my rectangle. I'm getting here the ratio so that if it's not a square image, the rectangle is matching the ratio and stretch accordingly. So that's all we need for here. And now the last part is going to be the description. So if I go here and I run the code, you see I also have this loading screen, which is here, this loading indicator. And when the server is going to return, I should have the description right here. Which is not the same because I didn't put the same temperature and it's not exactly the same seed. So we don't have exactly the same description as before, even though it's the same image. But I think you get the gist of it. So here, this is what I extract. This is what the whole thing return, like the whole API choices. So it's quite complex, but this is matching OpenAI's API, right? But what we need is just the content of the message right here. It's not the streaming mode. If you want to really have a more evolved, I would say, with the streaming, probably we need to first put the streaming here as an input, and then have a bit smarter output. So you basically concatenate all the chunks that you receive over time, and it creates a final text. I have examples of this in the other videos in WebLLM, so you can also check it out. If you want me to develop this a bit more, I can also make a new video on just remaking if you want, like a client for OpenAI here in Cables. But here the goal is really to emphasize on the Llama Vision part. So now we can start to test it, right? So what if this is easy, right? You just describe it and just an image, but here you can type any query you want. So technically you could also add, I tried this, which is actually pretty cool. What if we want to extract data from a page? So instead of basically parsing and doing the scraping ourselves by reading the HTML structure of a page, what if we simply, take a screenshot? This is a screenshot of the Llama 2 from Meta. And what if this is our prompt now? What if we say extract and transcribe? So let's see here. There. Sorry. Extract and transcribe the principal text information that the user would read on the page. Return the content as markdown directly, nothing else. So I tried to make this prompt. But I found it interesting because in my test it actually worked. So it means that if you want to summarize a page, basically, you could simply get a screenshot and the model would do OCR right away. And so you can start to ask questions directly on the screenshot. So we can try this. Let's try to first try the transcription. And then try to directly ask question about the page from a screenshot, which is pretty cool because if it worked, it means that it would do OCR and then some kind of reasoning on the text that it extracted. So let's wait a bit. So it's slow because I don't have a great GPU, but of course, if you want to sample and try to do this on a large scale, we need to go on the cloud and rent stronger GPUs, I guess. Okay, I get the answer right there. And you see, it's a big page, so it's easier to read here. But I mean, it's not, if you think about it, it's actually quite good, no? If you think, it's just I gave the screenshot here and it extracted everything. So now, let's try in one go. In the query here, extract and summarize what the page is about. Let's think step by step. Please be accurate. So I'm using the step-by-steps to basically have a kind of a chain of thought pattern, and just let's let it run. Let's see what happens. All right, so what do we have here? Okay, it shows a screenshot of the website, which appears to be a page about the Llama model. And then some kind of, so it worked. Basically, we can now start to interact directly with screenshots. So to me, this is quite impressive because for web scraping, for now it's not worth it because first it's very expensive to run and it's very slow. But this is just a matter of time before this becomes the standard way to scrape pages, because then you don't need to care about how the UI has changed and that you rely on this and this div to be able to parse the text. Here it's actually smart enough. I tried with just, for instance, a Facebook page, and it would extract only the middle column. So technically it's smart enough to understand the structure of the page and to know where the information is supposed to be located. I know some people have been trying to just take a screenshot and recreate a design, so like generate React code or whatever to recreate the website. But to me, I'm more like a data guy, so this is very, very interesting to be able to extract information like this, both from the text and prompt the image, basically. So yeah, here we have it. It's actually quite simple. This is gonna be, everything is public already, so you can just one line to run the server once you install it with Poetry, and then here you can simply clone this template and start to query it or modify and add more things, and start to play with the Llama 2 11B. So I cannot run the bigger one because I don't have enough VRAM on my GPU, but I think it's actually powerful enough to do some great things. I really hope that you like this video. It was a bit more Python oriented and technical. If you like it, if you have any comments, please let me know. Otherwise, I'll see you in the next video. Bye.